So that's the Raspberry Pi 5 reading temperature, humidity, pressure and air quality from a BME680 sensor and pushing every single reading straight into AWS IoT Core. Hello everyone, I'm Hariharnath and welcome to IoT Frontier. Today we are going to connect Raspberry Pi 5 with BME680 sensor and send the values to AWS IoT Core using professional approach. So for this, first we would need BME680 sensor. So this sensor will give us temperature, humidity, barometric pressure and VOC gas sensing capabilities. And then we need to look into this Raspberry Pi 5 pinout diagram. Try to connect this BME680 to this Raspberry Pi 5. So we'll be using 3 volts ground, SCK and SDI. So we'll be connecting them onto this Raspberry Pi 5 and this is my connection. So once this is done, we should be able to get to the next step, that is AWS IoT. So first you need to log into the AWS. You can create if you don't have. So once you have done that, you just need to search for IoT Core and open that service. And inside that service, you can directly click on connect device or click on one device. So here you should be able to check whether you are able to ping to this server or not. So first, before this, we need to open our Raspberry Pi. So I'll be using SSH pi @ I need to provide the IP address, or you can use raspberry pi.local. So I'm using IP address with Angry IP scanner. So here I have scanned with this IP range of my local network and sorted with ping. So I could see this 195 as my IP address of the Raspberry Pi. So I'll use this. So I have already saved the password, so I don't have to enter it. Now once you are inside this, you should be able to check the ping response. So copy this. Now you should be able to see the ping is properly coming, which means that you don't have any firewall issues and other issues. So you can stop that. You need to click on next and create the device name. So I'll be using device name as IoT Frontier and Raspberry Pi 5 BME680. So click on next. And because I'm using Raspberry Pi 5, it is Linux based and also I'm going to use Python. So based on that, we can select this and click on next. So we need to download this connection kit so that it will download all the keys like this. So it will provide the certificate, private key and also testing script. So once this is done, we need to open again the Raspberry Pi and you need to create one directory. So that is AWS_IoT. I have created AWS IoT as folder and then get into that folder. So now if I want to copy whatever I got that zip file into this, I'll use something called WinSCP. So you can download this WinSCP. So this will be using SFTP and you need to provide the host name of the same Raspberry Pi.local and the username and password. So log in into this. So here on the right side, you can see, so this is our Pi and the file system of that. And in the left hand side, you can see this is my local system. So I can go to downloads and then sort by changed. And here you can see this is the connect device package. I got it. So I'll just drag and drop into this AWS IoT. That's it. So now what I can see is use ls and you should be able to see that. So I'll just unzip this. Now you can see these are the different files. So I can just remove the connect. So once these certificates are extracted, we can follow the next step. So first we need to make sure this start.sh is executable. So we use this command. And then before starting this .sh, we need to do some more steps. So I'll give you those steps here. So we need to do virtual environment we have to set up. So first I'll use this apt update and then install this Python 3 virtual environment and build essentials, etc. So you need to run this. I'll provide all commands in the description. Once these libraries are installed, we can create a virtual environment. So this is the virtual environment creation step. And then we need to activate this virtual environment. So inside that, we need to first upgrade the pip and then install the AWS IoT SDK. So once this is done, we can also install BME680. So this is the library for our sensor. So now we can start using this start.sh. So you can see it is trying to download the CA certificate and then trying to send the values to the cloud. So I can just check in this run tech connection kit itself, you can see the values are getting updated and it is trying to show the current date and all the values. So if you are getting this clearly, then it is properly connected. So you can stop this and go to the continue, and we can see the device is connected now. So we open view thing. So this is how your thing has been created. So once this is created, we will set up our code. So before setting up our code, we need to check our I2C, because this BME680 is going to connect with I2C. So we are going to use I2C connections, that is in this way. That's why we need to make sure the interface is enabled in Raspberry Pi 5. So you can use this and check whether this is available or not. If not, you can directly go to sudo raspi config. So if you open that, inside the interface options, you need to use I2C and toggle this to S and click on enter here, and it is enabled now. So once this is enabled, you can exit and then you can use reboot option. So it will reboot. So I have already rebooted and then it is enabled. So that's why I am able to see this value here. So if you are able to see that, which means it is working properly. So next we need to check that is at which I2C port or the number it is connected. So I'll just use this I2C tools to install and check detect. So now it is connected at 77. So which means that it is not at the default 76. So based on this, we need to modify our program. So if it is 76, you just need to use something called I2C address primary. If it is 77, you need to use I2C address secondary. So I'll mention that in the code while I'm showing it. So we need to create this Python file. So I use nano for this and enter, and here I'll paste the code. And if you see, you just have to change few things. So if you use the same thing as mine, you just have to check whether you have this certificate path exactly like this, home pi AWS IoT, because I've created AWS IoT on top of this home pi. And here these are the certificate files I have, and this is the client ID and topic also similar one. And you want to check this endpoint, so you can check from the AWS IoT. So go to AWS IoT and then here MQTT test client, and in the test client go to connection details. You should be able to see this is the endpoint. So once you cross verify that, you are good to go. So as I mentioned, we got that as a sensor which is secondary. So I need to modify, so that is whenever we are initializing this BME, I need to mention this is as a secondary instead of primary. So I'll use capital secondary so that it will use the correct I2C address, and remaining code just try to publish the values of temperature, gas resistance and those things. So for saving this, you need to just use Control X, then you need to mention Y, then enter. So then it will be saved. After this file is saved, we need to verify whether it is working or not. So for that, I'll just use Python 3 command. So the code is successfully running. Now the critical thing is whether the values that we are sending from here are being received in our AWS IoT or not. So that we need to check. So we need to go to our thing. So we have this thing newly created for us, and in the activity you can see right now it is not able to connect, or we're not able to see something. So you can use MQTT test client as well. So inside that you can subscribe to a topic that we have, that is IoT Frontier RPi BME680, and click on subscribe. We need to get some values. We are able to send it properly, but we are not able to receive in AWS IoT. So this is the most common thing for anyone who is new to AWS. The problem here would be because of the policy. So they have very restrictive policy in AWS. So first we need to go to our thing and go to the certificate, and inside the certificate there is a policy. So if you get into this policy and open JSON, you should be able to see that they are using something called SDK. These are the resources from which it is allowed, but we are not directly using this kind of SDK. So the problem is it is not able to receive. We need to create a new version. So we can click on edit active version and go to JSON, and we can build our own policy. So I'll provide this policy. So I'll just replace this. So I'll say I'm using the client name as IoT Frontier Raspberry Pi BME680. So this is the client name I'm using. So that's why previously it was not working. So I need to provide this, and also topic, what is the topic it has to allow, and also in the topic filter, what is the topic filter. So all three things we need to provide, and the only thing that you need to change is this value, that is your AWS account ID. So that would be available from here as well. From here without hyphen, you need to copy and paste it here, and once this is done, click on save as new version. So I can also make it as active by selecting the second version and set as active. Now it is active, which means we can check our thing and go to the activity. Now we can directly go to MQTT, and we can again use the topic filter. So now once I have subscribed, you should be able to see these values. So after subscribing, if you are not able to see properly, again you can restart this Python code, and then you should be able to see these values. So you can see all the latest values are being shown here. So we can see all the 4 values coming from your ESP32. So in the next video, we can also send these values to some other consumers such as InfluxDB and show on Grafana dashboard as well. So if you found this video informative, please type helpful and smash that like button. If you want to learn IoT from scratch, then you can check out my course on Udemy from the link in the end screen. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.